Well, welcome. It's a dreary Sunday in Pittsburgh and the Steelers aren't playing, so we're going to do an update video on the sound system or 48350 amp from Rockola 453 to 474 and the problems that are occurring. The last video I did was in 2022, and at that time, just replacing the electrolytic capacitors and the PEC4 units was really all you had to do, and most of those amps came back to life with those simple maneuvers. But since that time, I've fixed about 40 more of these, and more and more problems are showing up as each year goes on. No components last forever, so just replacing the caps and the PEC4s is no longer enough to assure yourself that your amp is going to sound good. And the additional problems that we're having now relate to the preamp board, those op amp units. We're going to be replacing those. We have resistors in the driver boards that are getting noisy. We have AVC board transistors that are getting noisy. We also are replacing the heatsink transistors if their voltage bias is under 0.5 volts. We're also replacing any of the tropical fish capacitors, and I'll show you what they are, that are in the signal pathway, just because those capacitors are wearing out faster than some of the ceramic ones. Also, any of the rotary switches need to be exercised. Also, the on the tone control board there, the the bass and treble switches need to be cleaned. The volume control plug needs to be cleaned. Even the fuse holders are going bad. Those 3 amp fuses on the top, I've had a couple of them short out. And then the last issue I wanted to go over was solder joints. Several of the boards have points of stress that are starting to fracture. That you can't see them with the naked eye very readily, but we are resoldering a lot of the connections on the some of the boards, and I'll show you how to do that, and that's eliminated some of the issues. Noise is getting to be a problem. It's not just hum or loss of channel that we've talked about before. Noise is an issue, and we will just talk about noise in general from an amp and how to isolate it, divide and conquer, and deal with it. So if you're interested in sound, then look at this video. If you're not going to do any amplifier work or not fuss with it, then maybe pass on this video. But if you're having sound problems, this may be of value. So we'll start with the amplifier in general, and this is the amplifier. My brother Tom fondly calls this the lunchbox amp. I guess it looks like a lunchbox, but it's a wonderful amp. It is very serviceable. Has modular components that can be swapped in and out if you're having trouble. So let's get started on it. So here's our amp, and we've removed the 3 screws that secured it here, and then you push down the tab and this will free this to come forward. Usually you take off the mute relay. Well, this one has a loose cover, which is fine, but you don't really need the mute relay if you're going to be if you're going to be servicing the amp, because you want to hear it. You don't want to hear it muted. This is the speaker overload light. It should, when the amp is playing, it should be very dimly lit. If it's brightly lit, then you have a problem and you have to reassess things. This plug is not used. All these plugs on the bottom are self-explanatory. When we service the tone control board, we'll remove the 6 screws that are needed to be loosened so that can be serviced. Over here, always service the volume control plug. Those 6 prongs, they need to be cleaned, and then you can reseat it in its space there. And then just examine the 2 Molex connectors to be sure all the wires are intact. This you can leave alone. There's 2 fuses here need to be looked at, and then when we open this up, we'll look at the inside as well, the fuse holders. I don't know if I can show them properly here or not, but they're on the inside. You gotta check continuity across the holders as well, as I had some shorted ones. This large capacitor gets replaced, and you can see what I did there. I put a 2200 in. I just disconnected the negative lead from the original, the positive lead from the original can, and put this across. This goes to ground there, and the resistor and the power lead go to the positive lead of the capacitor. Just be sure you get that polarity right. The negative goes to the can, and it's pretty self-explanatory. But that way you can leave the original can in there, and this one the replacement is smaller, so it shouldn't be a problem. Now we're gonna service all the boards here. This is the capacitor board. When you take this out, you got to take lots of pictures because there's lots of wires that go to it. It's easy to get them off, but it's tough to get it back on. So this is the volume control. You always exercise that and clean the, spray some contact cleaner on it. All these connectors need to be opened up and reseated. This one, there's 3 there, and there's a big one on the door here. Now this is your supply board. It's very important. We'll go over that. This is your AVC board, 2 preamp boards, 2 driver boards back here behind this shield. We'll take the shield off. And then behind there are the 2 heat sink boards that we'll also look at. So we'll do each component individually, and then we'll talk about sound noise issues and which boards are causing which problems, etc. Before we go to the boards, the individual boards, I want to just walk you through the schematic. Now this is from the wiring diagram. This is 48350 amp. So we'll start. Here's your input for left and right channel. We'll just use the left channel, but it goes in on contact. There's a 2-prong connector at the preamp board, so that's the start of your signal. And then we'll just walk it through. It goes through the preamp board, and this is a tropical fish capacitor, C1. This is your op amp unit. And look here, C5, C6, and C9 are all tropical fish capacitors in that signal line, so they all got to go. So I just wanted to point that out. There's 4 of them there, and those are not electrolytic, so this is what we're doing in addition. And then the signal comes in and goes over to the volume control, comes back from the volume control, and it goes on, from the volume control, it goes on pin 5 and 1 into the tone control board. Now we'll just trace, and that's pins 12 and 13. So this is where you want to check your signal again on 12 and 13 of the tone control board, because the signal rattles around through all these bass and treble switches in the volume control. Any dirty connection there can interrupt your signal or cause noise. So all those slide switches have to be serviced. And then when you get over the driver board, you're coming out of the tone control on 11 and 14, and you go into each driver board on driver board pin 7. So that's where you check the driver board for your signal. So once it gets into the driver board, where does it go? Through that tropical fish capacitor C26. So that has to be replaced along with the other can stuff. But I'm just giving you my rationale here. And then Once it gets through the driver board, it goes out to the heat sink and then on out to the output transformer and speakers. So that's just a very quick overview. So let's go to each board now and talk about it individually. So we will start with the capacitor board that's been removed. This is an original one, and this is 1500, 1500, 220, 100, and 100. Those are your 5 cans. They need replaced with quality replacements. And check the resistors over here. This is your output going to the output transformer. So these resistors are each 10,000 ohms. Be sure they're very close because that's important. In fact, everything on this board is important. You really should check all the components. These are your 2 power rectifier diodes. Check them. These capacitors seldom go bad, but if they're obviously cracked like this, I would replace them. I think they're 0.027. Check all the resistors. There are several diodes here. Everything really should be perfect. None of these components are scarce or they're all available and cheap, so please check everything here. Now notice that this has 2 resistors here, and here's another. This is a capacitor board I rebuilt. This one has the fuses. I think this is a little better one. These are 0.25 amp fuses, but it's still the same process. You've got 5 capacitors to replace, and I've been using radials because they're a little less expensive, and I have to extend the 1 negative lead over here. It's a little more work, but the end result is good. So yeah, again, 5 capacitors. Check everything there. Check those power diodes up there. These caps were good. And then go to the back and be sure all the connections are good and nothing looks bad. Incidentally, on this one with the resistors, look at that back. It looks like it's been toasted a little bit, and although it still worked, you just don't like to see that. That's of course they had some asbestos there because they knew it was going to happen, I guess. But this is a more common board you'll see in the United States. So get familiar with it. There's nothing there that's difficult. I should say the only thing difficult about that capacitor board was getting it back in and all the wires connected properly. So hopefully you took a lot of pictures. All right, we'll go on to the next step through the amp. It goes to the preamp. The preamp board has only 2 can capacitors, and I believe they're 22 and 10. Check that, so that's not much, but I have been replacing those tropical fish capacitors that are in the signal pathway, and it's this one here, 0.47. I believe this is 0.27, and these 2 guys are 0.1. So you're going to have 4 additional capacitors to replace there. The PEC units are usually good on these. We are also replacing this 48934 op-amp unit with 4558 unit. You can get that on eBay. Exercise the just the rotary resistor here, spray some contact on it, leave it in sort of the mid position. And then the other thing we're doing is we are, with these connectors that stand up and are subject to stress, we are reflowing these solder joints. So, and we're going to do this on pretty much all the boards. So this gets resoldered all the way down the line here, just because there are some microfractures showing up, and this is causing intermittent sound and noise. Okay, that's the preamp board. Remember, there's 2 of them. That op-amp unit is 4558D, I believe. You can get them on eBay, as I mentioned. Okay, next board is the AVC board, and this actually is positioned about the same way through as the preamp boards. They interact with each other. So again, this is before the volume control. So if there's noise, that varies, gets louder with when the volume's turned up and lower when the volume's turned down. It could be the preamp board, it could be out front at the cartridge, or it could be the AVC boards. Any rate, again, we are reflowing these connectors here that go to the prongs of the pin. So resolder those. There are only 2 electrolytic capacitors to replace there, but notice that I'm replacing again those tropical fish, so that's C13, C12, and this C10 over there is 0.2, okay? I'm checking the transistors there, but I'm not replacing them unless there's a whole lot of white noise we'll talk about later. Normally, I don't replace the PEC unit. I did it on this one because I was experimenting and it didn't really help much. But the point is, if you have to replace the PEC unit, it's just 4 resistors and you solder them in. I obviously checked all the diodes here, and one of the resistors up here was bad, so I replaced it. But that's what you got to do. This is the AVC board. It is important, and but not a whole lot of capacitors, fortunately. Next, this is the supply board. Now, this is where a lot of your voltages come off of. The voltages are higher on this board, so notice that some of the resistors are a little higher wattage. There are 6 capacitors here, 150, 150, 10, I believe it's 22, 22, and 47. So 6 electrolytics to be replaced, and I am replacing this guy here too, this tropical fish capacitor. It is C33. I can't remember the value, just look it up. You will need to check all these resistors, check this diode here, and all the diodes. Really check everything, and then reflow the same connections here that go to the push-on Molex. There's a large resistor under there. It has 2 values. I believe one is 820 and the other is 2700. It's under there, you can't see it. This is actually a switch that is seldom bad. And there's also the SCR here, which is seldom bad. But this diode C12 can be bad. This resistor can be bad. And all those caps obviously have to be replaced. This is very important. Spend some time on this. It's a little tougher to work on, but it is critical. Here's your tone control board. Now, this one, you have to free it up by loosening 6 of those little hex nuts on the front panel, and then it'll slide off. You take the connector off, and this is very important to reflow the solder joints on there. In fact, you can probably see that some of these don't look so good. So doing that will help you with some connections, because sometimes these guys are loose, believe it or not, and if you have to reflow the joints. Now, I replaced capacitors. I think I was just bored one day. I really didn't need to do that. The capacitors and the resistors on this board are usually good. What is not good are the connectors on the gang Molex there. They get loose. This is the volume control, the mute relay plug. Just spray some contact cleaner in there. But these guys, all the slide switches have to be exercised up and down. And so spray some WD-40 and get them all lubricated, and then clean it with CRC, because they all have to make and break, because the signal goes through every one of those guys. And if they're not quite right or dirty, your signal gets interrupted. You have loss of one channel, and you're out of business. Now, the balance control here, I usually just clean spray some CRC on it, move it back and forth, and leave it at the mid position, and then I reinsert this board. If you do those things, you almost never have any problem with it. Now we have the driver board, and there are 2 of them. This one is one I've already serviced, and it's not a real good one, so it's a spare, but Notice that there are, I'll go to the manual here. There are 3 electrolytic capacitors, 100, 22, and 10. And here they are, 100, 22, and 10. They need to be replaced. Also, that C26 over here is a tropical fish capacitor. It gets replaced with a 0.047, either a ceramic or film capacitor would be fine. And then this is that PEC cocoon unit, and you replace it with the 3 resistors and the 150 picofarad capacitor. Check all the resistors on here. These 4 are 2700. If they're not within tolerance, if they're more than, they often creep up. So if they're read more than 3000 ohms, replace them. Some people replace them regardless because they are getting noisy. And then all your diodes need checked. This other resistor, R19, is 100 ohms. Often it's out of tolerance. It takes a lot of heat. So be sure you check all the resistors. Everything on this board needs checked. And then the transistors you check per protocol. These 2 transistors are seldom bad, but these guys can be bad. And if the heatsink transistors are bad, then you look back and you have a 50% chance of these being bad. So, but since you usually check these first, check everything. And then don't forget to reflow the solder joints here. This is an important board. This is getting toward the end of the game here, and the voltages are higher. The precision has to be a little tighter. Okay, here's the last 2 units, the heatsink units. Now these are in the back. There are 2 connectors. I usually separate this and reseat it. This one here goes to the driver board, and this one down here goes out to the speakers. When you put these guys back in, be sure that these guys are reconnected. Do not ever put them back in and forget to do that, or you're going to blow out your transistors and ruin some stuff. Now, these 4 resistors need to be checked. 2 of them are, I think, 0.75, and these are 100 ohm. Here, I already scavenged one. On the back are your heatsink transistor, and you remove the screws, take them off. They come right off. See that Molex, I'm sorry, that shield there, the heat shield needs to be in place. There's some heatsink compound you use, but at any rate, you'll check these, and I've shown you how to check them before. I'll do it briefly just here in a second, but these are critical. These have to be good. And if they're borderline, replace them. They're about $3. They're 2N3055. The original was NTE 130, but this is the one you want. 2N3055. A NPN power transistor. And then put it back in. Be sure all the shields are there, and then reinstall it. And when you put it back in, besides being sure the connections are made, make sure the screws are tight. This has to make a tight seal with the case in order to allow for better heat transfer. So here's how we check those heatsink resistors, transistors again. Put your, on the capacitor checker, the positive goes to this is the base emitter collector, and base emitter always has a little more voltage drop than the base collector. There's a few more impurities. So we put the positive on and this reads 0.455. That is not shorted. Let's get here. Go here. This is 0.448. And then you just check reverse polarity. There should be open line. Should not be any shorts, and there aren't. But that reading of 0.456 is too low. This is to me is a tired transistor, and I replace it. Now here's the new ones. You can get these from DigiKey. You can also get them from Anchor Electronics in California. They're cheaper. I wouldn't just buy them off of eBay indiscriminately. I've had some problems, but here's a new one, and look. It's reading 566 millivolts versus 450. So this is a strong transistor. Again, always check reverse. There should never be any base collector. Emitter collector short. It always should be open line. So this is a very good one. This is one I ordered. This is what I put in when the original ones are like this, weak or shorted. Okay? Put them back in with some heatsink compound and that mica shield. Screw them in tightly and replace them. Put the unit back in. Put everything back in carefully. Be sure to get all the connections proper. At this point, you probably would just put your amplifier back in your jukebox and test it. For me, I do hook it up to the power supply and the output transformer and 2 speakers, and I put the connections over here. By the way, make sure these connections are always snug because the signal goes through there. And always be sure, I'll show you the diagram here. On the front of the power supply, the amplifier white Molex, be sure that you have 46 volts AC between the center tap and the top and the center tap and the bottom. There's 2 leads that come over to give 46 volts for each channel. Be sure that's correct, or you may ruin your amp. I've seen that happen. Because the amp doesn't exist in isolation. It's got a lot of components to depend on, so always be sure to do that. But at any rate, we are now going to plug this in, and I'm going to check voltages on these pins. The preamp board, it would be pin 4 and 5. The driver board, pin 1, pin 3, and 4, those voltages. And that's basically it. The other 2 are duplicates. And that's what we're looking for. And on pin 3 there of the driver board, we are going to do some bias adjustments on the red rotary resistor to get it to 32 volts if it isn't 1/2 of 64. And the same for pin 4, it shows 0.5 volts. And that's on this connector here. If it doesn't show 0.5, then we will adjust this yellow rotary resistor in order to get it to 0.5 volts. Those are the 2 bias adjustments you need to make. But I'll just show you quickly what I do, and then we'll finish up with some questions on noise management, etc. So I plugged this in through a current limiting bulb, which didn't show anything. And I don't have any abnormal sound. When you put it at high volume, you will get a little bit of white noise. I don't know if you can appreciate that, but that's pretty much normal. When you're in playing range, you really don't notice it. So we are going to do voltages here now. I told you first the preamp board, 4 and 5. So here we go. Right here on 4. And that gives us 15 volts. That's good, plus 15. And when we go to the other pin 5, and that gives us 1490, so that's good. And we'll go over here and do the same, 1520, and here the same, pin 5. 1490. We'll go over the driver pins. Now, again, we're looking at pin 1 should be 64 volts. It's on top. And we get 64.3. And over here, 64.4. And here, 31.89. So we can adjust that red resistor down there a bit. And here, 0.54. That's good. And we'll do the same over here. All of our voltages turned out good, so I'm pretty happy with that. Now we will also do our bonk test, and I'll show you how to do that here, if I can find my probe. Right here. Here's your input. See how good? That's nice. There's the one channel. Here's the other channel. Both channels sound wonderful, really. And then you go over here to the side of the tone control, and you do 13. It's not very loud, but it's there. And you do 12. Okay, coming out of there, it's good. That's 14 and that's 11. Both good. They'll be the same as you would get over here on the driver board, which is right here, pin 7. That's good, and here. So that's pretty much it for testing. We would now put it in the jukebox and play it, but our voltages are good, and our sound quality certainly seems good. We're going to summarize what we've done in this video to improve overall sound and reliability of the 48350 amp, and to try to eliminate the white noise, which we're getting more and more of. We know that the PEC4 unit on the driver board was a noise maker in the past, and we have dealt with that. Speaking of the driver board, these resistors are 23, 22, 16, and 17. They're 2,700 ohms. They are noise makers as well, and if they're off at all when you test them, I would replace them with 1 watt 2.7K resistors. Q3 can also be a cause of noise, even if it tests good. It is a it is MPSA 56. Note that can be either a GE or a Motorola position. I'm sorry, I got my sheets mixed up here. The GE position has a different pinout. What's in there is usually the Motorola, and usually you will be replacing it with a Motorola, but you just don't know. I want to caution you when you replace those transistors. Also on the AVC board, we were replacing the additional tropical fish capacitors. I'm going to summarize them at the end. Over here on the preamp board, that IC unit, little black unit, is 4558D. You can get those on eBay. I think it was electrolytic, and the capacitors were, again, I'll summarize them at the end, what we've done. The driver board we talked about, the AVC board we talked about. Those are the three main capacitor board. There's not too many causes of noise there if you make your soldering appropriate. Tone control, again, we talked about what to resolder all those connections, which is probably more than enough. Now let's just look at what we did here. The capacitors we're replacing now, the ones with an asterisk are tropical fish. The other ones are the usual canned capacitors. So let's just go down this list. You can maybe keep a copy of this at home, but you're replacing quite a few now, okay? A lot of them aren't that expensive. They're certainly reasonable, but, and then resistors. Here are the troublemakers here. These are mostly on the driver board. that 100 ohm resistor R19. Please check that. Please check a lot of them, but those are the main ones right there. R34 is on the supply board. It can either be 2700 or 620. Make a note of that. It's 2 watt. And if you replace it, be sure you replace it with the right one. And I mentioned the transistors. There's 2 on the ABC board, Q1 and 2, and on the driver board, Q3. Well, hopefully with the improvements and replacements you've made, you won't have much noise or hum or other distractions. If you do have hum, there's one more thing you can do. You can reseat this all these gang ground connectors that are inside that door. You'll see them on the bottom. Reseat all of them. Sometimes that helps if you have hum for no other reason, and you shouldn't really, because you've replaced all the troublemakers. If you do have white noise or noise, remember, check to see which channel it is, either one right, left, or both, and then rotate your volume control. If the noise increases when you increase the volume, then it's going to be probably the preamp board or the AVC board. And if it's just in one channel, well, it's probably going to be one of the preamp boards. So you can swap those boards and then see if it changes sides. Well, then you know you got a noisy preamp board, and you just start changing resistors and components there if you don't have an oscilloscope. If the noise doesn't change with moving the volume up and down, it's probably the driver board or output. And again, if it's one-sided, you can swap the driver boards and see if it changes sides, and hopefully you'll get lucky. We have those resistors on the driver board and that Q3 transistor are suspects. So that's pretty much it. I hope you got something out of this. Sound is important, and I just felt that I had to update viewers a little bit here, because the previous video did not cover enough material to up your ante here as far as getting your chances of getting a good result. Well, I hope you all have a nice holiday, and next video will probably be on the Seaberg. I'm looking to get another Discotech or SS160 in, but probably won't be for a while. Okay, till then, happy juking. I hope you all get your boxes working and sounding fine.